In this video, we're going to look at the curvature of a function of one variable and determine where that curvature is as large as possible. So in this case, we're looking for when the function y equals log x has maximum curvature, and then also asks what happens to the curvature as x gets large. Alright, so if we're going to figure out when it has maximum curvature, we need to calculate the curvature function to start with. So we take the first derivative, which is 1 over x, the second derivative, which is minus 1 over x squared, and plug it into our curvature formula. The absolute value will take away the negative sign in the numerator, so we're left with 1 over x squared over 1 plus 1 over x squared to the 3/2 power. We can combine like terms, or excuse me, we can get a common denominator and combine in the denominator. And then rewrite your denominator, take your 3/2 exponent and distribute it to the numerator and the denominator in the denominator. And then invert and multiply to simplify to x over x squared plus 1 raised to the 3/2 power. This is your curvature in terms of an arbitrary x. This is the function that we want to maximize. In order to find a maximum of a function, we need to take a derivative. Here's the derivative using the quotient rule. This derivative simplifies to 1 minus 2x squared over x squared plus 1 raised to the 5/2. Looking when a fraction is equal to 0, that's when the numerator is equal to 0. We see that the numerator is equal to 0 when x is 1 over root 2. We don't need to worry about the negative 1 over root 2 because that is not in the domain of our original function. Only 1 over root 2 is. You can check that this is a local maximum by using your first derivative test. The derivative is positive to the left of 1 over root 2, and it's negative to the right of 1 over root 2, so we really did come to a maximum. It's also the only critical number from 0 to infinity. It's the only one we found on the entire domain of the function. And this function is continuous on the entire interval. So what that means is that we have exactly one maximum, and everything else has to be lower, so that 1 over root 2 is a global max. So we get a global maximum at 1 over root 2. Plugging that in gives us the point that gives us where the curvature is at a maximum. For the second part, asking what happens to the curvature as x goes to infinity, well, the numerator of your curvature function here is x, so it's x to the first power. The denominator behaves like x cubed. So the fraction is x over x cubed, essentially, as x gets large, or essentially this looks like 1 over x squared, which goes to 0, so we see that the curvature goes to 0 as x goes to infinity.